Okay, the next thing we need to do is talk about what we mean by an event. Um, so if I say the probability that it will rain, then the event that I'm talking about is that it will that it's raining. Or the probability of getting a 5 when I toss a die, the event is getting a 5. So whenever we use the word probability, there's always some event that we're talking about. So we want to define what we mean by this word, event, carefully. Now, as I said, you're supposed to know about sets, and so you're supposed to know about what we mean by a subset. And if you recall, a subset means anything that is if A is a subset of B. Let's see, can I draw something here? Just make a picture of it. Okay, so here's A and here's B. So everything in B, every element of B, is also an element of A. That's what we mean by the word subset. So we have two sets, and if every element of B, so you look at all the elements in B, if they're all also elements of A, then we call B a subset of A. Okay, so they say for motivation, consider the die tossing experiment in example 1. And let E denote the event that an odd number comes up when we toss the die. Okay, so we talk about for example, we might ask the question, what's the probability that we get an odd number? So the event is getting an odd number. So let E be that event. If, when the experiment is performed, one of these sample points results, so if I get a 1, or a 3, or a 5, then I would of course say that I got an odd number. In other words, if I toss the die and I get a 5, then of course I would say that I got an odd number. So if any one of these sample points occurs, then we'll say that E has occurred, because E is getting an odd number. Thus, to say that the event E occurs is equivalent to saying that the experiment results in an outcome in the set 1 through 5. Okay, let me say that again. Thus, to say that the event E occurs is equivalent to saying that the experiment results in an outcome in here, right? So to say that we got an odd number, that is to say that E occurs, if any one of these happens, then we say that E has occurred. Okay? This suggests the following definition. An event is a subset of the sample space of an experiment. This is certainly and clearly a subset of the sample space. The sample space is 1, 2, 3, 4, 5, 6, and E is 1, 3, 5. It's clearly a subset of here. In other words, everything in here is also in here. So it's a subset. So what that suggests that maybe what we should use for a definition of event is subset of the sample space. Okay? Let me say that one more time. An event is defined to be any subset of the sample space. So this subset is this is one subset, and this one we usually call getting an odd number, but we could choose any subset from here and say it's an event. For example, we could say F is this subset of S, and this would also be some event. You might give it a name in words. You might say it's the event that you get a number greater than 3 when you roll a die, but it's this particular, we call it an event because it's a subset of S. What name you give it, like in English you would call it the event of getting a number greater than 3, or you just call it F or whatever, that's different, but it's a subset. It's a subset, and therefore it's an event. It's a subset of the sample space, and therefore it's an event. So let's look at example 7. Consider the experiment again of tossing a die and recording the number on the top face. If E is the event of getting an even number, so this is E, this is just what we just said, and if F is the event of getting a number larger than 4, then F would be this, subset. It's a subset of the sample space. In a germination experiment, 10 corn seeds are planted, and the number of seeds that germinate within 30 days is recorded. So we put 10 seeds in the ground, I guess, and we see how many of them sprout. So the sample space is what? Well, maybe none of them sprout, or maybe all 10 of them sprout, or maybe 2 of them sprout. This is the sample space, the set of all possible outcomes. The event, let E be the event that more than half of the seeds germinate. So E would be what? 6, 7, 8, 9, 10. So it's a subset of S. Okay, let's go to the next one. Consider the light bulb testing experiment in example 2. If E is the event that the life of the bulb is between 10 and 20 hours, inclusive, then E, remember the sample space was all t's greater than or equal to 0, but now we're choosing a subset of that. We're talking about the set of t's that are between 10 and 20. That's definitely a subset of the original sample space. And so this is some event. Okay, let's continue. So in set theory, we say that every set is a subset of itself. So if you have a set S, then you say S is a subset of itself because every element of S is in S. Okay, and also we say that the empty set is a subset of every set. So if you don't remember this, please go back and check about set theory. But we say that the empty set is a subset of every set also. So if S is a subset of itself, then S itself will be called an event. In other words, in addition to calling S the sample space, since it's a subset of itself, it's also an event. And since this is a subset of every set, it's a subset of the sample space, and so it's also an event. So if the sample space of if S is the sample space of an experiment, then S and the empty set are events since they are subsets of S. Then they go on to say, whenever you perform the experiment, the event S must occur. Because how do we determine whether an event occurs? Up here. If E is an event E is said to occur if the outcome of the experiment is an element of E. So S will be said to occur if the outcome is in S. But of course the outcome is in S because S is the set of all possible outcomes. So they say in any performance of the experiment, the event S must occur, and this one cannot occur because in order to say that it occurs, we have to find something in there that's in S, but there's nothing in here. Okay? So for this reason, S is called a certain event. It has to happen, and this one is called an impossible event because it cannot happen. Okay?